take a moment, pause this, and set up your page so that you can take Cornell notes in your spiral. This is Unit 2, Ecology 1. This is B12D. And in this instance, what you're going to do is you're going to describe the flow of matter through the carbon and nitrogen cycles and explain the consequences of disrupting these cycles. So we're going to do the carbon cycle first. And again, you're going to explain the consequences of disrupting it, and you're going to explain how the matter flows. So we want to look at how carbon flows through a cycle. You guys have done this before in your other classes with like the water cycle, and you can follow a drop of water through evaporation, condensation, things like that. So now we're going to do that with carbon, and then we'll do that with nitrogen. So here we have the carbon cycle, and again, I'm going to go a little bit fast on these, so pause this whenever you need to. The carbon cycle, everything begins with carbon dioxide in the atmosphere, and everything ends with carbon dioxide in the atmosphere. So the carbon dioxide is in the atmosphere, and the carbon in the carbon dioxide, that's what we're trying to get to. So plants obviously take in carbon dioxide from the atmosphere. They use the carbon dioxide and water to go through that process of photosynthesis, right? So letter B, they use the carbon to make carbohydrates for energy. Okay, anytime again that you see capital E in science, it's typically going to stand for energy. So we know that they're going to take the carbon out of this carbon dioxide, and they're going to use it to make carbohydrates for energy, and they do it in that process called photosynthesis. Herbivores eat the plants, taking in the carbohydrates that those plants made, converting them for their own use. So if you have that cow that's eating the grass, he's going to take that carbon out of the carbohydrates and get energy for it, and he's going to use it to make his own stuff. So we've now taken the carbon out of the carbon dioxide, and we've run it through plants, and now we've run it through the animals here, the herbivores. And obviously, when those animals, those herbivores breathe out, they breathe carbon dioxide out. And so right here you have one point where we just went through the carbon through the bodies, and now the carbon dioxide is going back into the carbon cycle. So part of that carbon is returned to the atmosphere as carbon dioxide. Atmosphere, that's what that abbreviation is right there. So the plants get the carbon out of the carbon dioxide. They use it to make carbohydrates. We eat those, whether they're herbivores or carnivores or omnivores. We eat those and get them into our body parts. And at this point, part of that carbon is returned into the atmosphere as carbon dioxide. But now we have the herbivore that's eaten by the carnivore, and that carnivore uses the carbohydrates for its own purposes. They convert them, they use some of the energy, they breathe some out in the form of carbon dioxide. So if this herbivore, if we just stopped at this herbivore, then it would breathe it out. But herbivores obviously are eaten by carnivores and omnivores. I mean, I don't know about you guys, but I like cheeseburgers. The herbivores are eaten by the carnivores, and we as carnivores, omnivores, breathe that carbon dioxide out, so we have some of it going back into the atmosphere. But no matter what, every one of those organisms are going to die. And in that process of death, once we die, decomposers work on the bodies, and they break things down. And a lot of those things, they're going to release that carbon back in the form of carbon dioxide. Gases are released in that form. So the organisms released waste products, and those are going to be broken down. Sorry, let's move this up some. Organisms release waste products, and those will be broken down, and you're getting that carbon dioxide back into the atmosphere. As the whole entire, not just waste products, but as the whole entire organism decays, that process always also releases carbon dioxide back into the atmosphere. So again, you have the cycle, and it starts all over again. It keeps going round and round and round. This is a big deal because it starts as a gaseous thing back up here. We start with a gas, we end with gas. So the carbon is in gaseous form because it's not pure carbon. It's in a compound with oxygen, and it forms that carbon dioxide, which you guys are all familiar with. Now, remember that we talked about humus or detritus? That's decayed, rotted material. We have all sorts of weird organisms that are going to be helping to break that down. But ultimately, all of that is broken down into a multitude of chemicals, and one of those chemicals is carbon dioxide. That's how the carbon gets back into the carbon cycle. Now, there are lots of things that we talk about when we talk about carbon, and one of those things is organic. We talk about the word organic a lot. If you go to the grocery store and they talk organic, they're really saying, oh, hey, we didn't put any pesticides or chemicals on this. That's absolutely not what we're talking about here. Organic in a science class refers to the fact that it's a compound that contains carbon. So if we're talking organic compounds, typically those are those carbohydrates, starches, things that have carbon in them. That's what we're talking about here. Now, we also have one other thing we need to talk about, and that's a carbon sink. Where is a lot of carbon stored in this cycle here? Well, one place it's stored obviously is going to be the atmosphere, right? That's where the carbon dioxide is. So that's a big part of it there. Another place would be, though, something like coral reefs or the ocean as a whole. It always contains lots of carbon dioxide. Coral reefs themselves, they have a long lifespan. The reef contains carbon inside of it, so it holds that carbon there. Forests, if you think about trees, they live for years, hundreds of years, many of them. And so they keep that carbon out of the cycle. It's staying in one place for a long time. Even if you talk about humans, the humans have an average lifespan of about 70 years. We're kind of a short-term sink. We don't live that long in the whole scheme of things when you talk about things like trees that can live hundreds of years like that. So a carbon sink is a reservoir, an area that has or contains a lot of carbon. And so here are just a couple of examples of that. So within here, in different areas, like in here in the plants, there's a carbon sink there. The atmosphere has a lot of carbon for carbon dioxide. And so you have places where you have a lot of that carbon in a form that's going to stay there for a while. It's got a lot of access to the carbon. We're going to talk about the disrupting the carbon cycles in the next section here.